Welcome to this lesson. In this lesson, we'll be treating solids and the different types of solids. So when we talk about solids, we are talking about that form of matter that has definite shape and also specific volume. That's definite shape and definite volume. So when we're talking about matter and different types of matter, we talked about solid, liquids, and gases. And we said that solids, they have the definite shape and they also have definite volume. We said liquids had no definite shape but definite volume, while gases had no definite shape and also no definite volume. So now we are treating specifically solids, which are the ones that have definite shape and definite volume. So let's see. Solids are one of the fundamental states of matter characterized by definite shape and volume, which I just said initially. Their structural rigidity arises from strong intermolecular or interatomic forces of attraction. So as I was saying, I said the reason why solid particles stay together is because the particles by themselves, they attract themselves, they hold themselves together strongly. So that's why it's difficult for them to move. So there's a strong intermolecular force of attraction, and this is the reason why solids stay strong or stay rigid. And solid can be classified. They can be classified based on their internal arrangement and also bonding. So as we have solids, we have different types of solids, and these types of solids can be we are splitted based on the internal arrangement of the molecules or the particles of solid, and also the types of bonding that exist within these solid particles. So let's see how the different types of solids that we have. So one of the first types we'll be discussing is the crystalline solids. So these type of solids are they are solids that are characterized with regular repeating arrangement of particles. So here we're talking about the characteristics or the types of solids based on the arrangement of particles. So for crystalline solid, it's a type of solid characterization or a type of solid classification where the solid particles are said to have a repeating arrangement. The particles are having a repeating arrangement. So you can see from this diagram, we have a constant arrangement that if you follow a straight line, you will see a symmetric movement. Big, small, big, small, big, small, big, small. Here we also have big, small, big, small, big, small, just the constant repeating arrangement in a regular pattern. So these kind of solids are known as crystalline solids. And examples include salts, quartz, that's our normal sand, metals like iron and copper. So these solids exhibit sharp melting points, anisotropy, and well-defined geometric shape. So what is anisotropy? Anisotropy is that behavior of solids where they behave differently if you hammer them from different angles. So if you, let me see, an example is like wood now. If you try hitting probably a tree, you cut a tree from the center and from the top, you cut a tree just leaving in the center log. So if you hammer the tree from the top, if you try to smash the tree from the top, it's difficult to compress it. But if you bend the tree down and try hammering it downward, it is more difficult. So these characteristics of solids to be having different behavior when you're hammering them or hitting them from different directions, or behaving differently when you apply different forces to them from different directions, is called anisotropy. So take note of that. And well, these are characteristics that are basically exhibited by crystalline solids due to their ordered internal structure. So let's move on to the next type of solid based on the arrangement of particles. So we have amorphous solids. So unlike crystalline solids, they lack long range orderly arrangement. So these are still solids, but now unlike crystalline solids, we say crystalline solids, they have a constant arrangement, a repeating arrangement pattern. We have small, big particles, big following small, following big, following small. So unlike that, those kind of solid, this kind of solid, they don't have that kind of organized or ordered arrangement of particles. So you could see them big, small, small, big, small, small, like something like this. You can see here, we see the particles, they don't have an organized pattern. Some of them are more distant from the others. Some of them have closer distance to themselves. So this disorganized kind of arrangement is the kind of arrangement that are known for amorphous solids. So they are not crystallines, and examples include glass, rubber, plastic. So if you look at this particular materials, they are known as solids, but now they don't have a definite shape. They have varying shapes sometimes. So these materials often soften under range of temperature and are often referred to as supercooled liquid. So if you remember, rubber, if you know some rubbers, they are formed by melting a particular certain material and pouring it into like if you notice when you're making plastic, they melt polymers and they move them into a mold. So when you pour them into a mold, they then take that shape that they have as their new solid shape. So they are known to be called, they're usually called supercooled liquid. because they behave like liquid in most cases. They don't have specific arrangements. So amorphous solids, they are also known as sparkle cool liquids. So that's what I'm just trying to drive at. So due to their irregular particle arrangements. So now based on type grouping, based on bonding type. So we've talked about solids. We talked about types of solid based on the arrangement of particles. We said there are two types. That's we have the amorphous and also crystalline solid. So now when we're talking about now the bonding, now we're talking about the types of bonding, trying to group solids, the different types of solid based on the type of bonding. We then have four groupings, which are ionic solids, covalent solids, metallic solids, and molecular solids. So each category displays unique physical properties due to the nature of forces that is holding their particles together. So we know that all solids, their particles, they have intermolecular force of attraction. That's their particles are being held together. They hold themselves. So now there's a way that the strength of the hold will determine a type of solid. So that's what we are heading into, how the type of bonding affects the type of solid. So now let's move on to the first, ionic solids. So these type of solids are the solids that are consisting of, they are made up of ionic bonds. So if you remember when we're treating ionic bonds, we said these bonds are formed by the exchange of electrons, or the exchange of electrons, where one gives out electrons to the other one, and they form both positive and negative species. So these kinds of solids, these kind of materials, they form what is known as ionic solids. So they consist of positive and negatively charged ions, and they are held by electrostatic force of attraction. So the kind of force that's holding ionic solids are known as electrostatic force of attraction. So the next one is covalent solids, and examples are diamond, quartz, and their likes, and they are bonded by the shared electron. They are, from the name covalent, we know that covalent are talking about solids or materials that bond due to the share of electron between themselves. So the solids also that are known as covalent solids, they also have the same bonding type, where the bonds are formed by sharing of electron, and they have a continuous network. So examples are diamond and quartz, as I just stated initially. So next type of solid based on bonding is metallic solid. So this type of solid, they are composed of metal atoms that are held together. They are held together by the movement of electron, the localized movement of electron across. With this, the localized movement of electron is known as sea of electron, because no particular atom or no particular particle of the solid can say it has the electron. All electron is owned by everybody. So because of that reason, that nobody has any particular electron, any particle that tries to escape, it's almost like it's not free, like as if they have like colonial master that's always moving around to check them continuously. So this movement of electron kind of keeps this kind of solid in a rigid shape all around. So these kind of solids are known as metallic solids that are held by the localized electron. So, and they have property of being conductive, having high electrical conductivity and even thermal conductivity, and they also are known to be malleable. That they can be hammered into sheets. They can be hit into flat cross sections. So let's move on to the fourth type of solid. We have the molecular solids. So this type of solid they include ice, sugar, and their likes, and they solids that consist of discrete molecules held together by van der Waals forces. So these kind of solids, they are held by a weak force of attraction like van der Waals force, dipole interaction, and also hydrogen bonding. So they are generally soft, poor conductors, and have relatively low melting points. So with that being said, I'm sure we should have been able to know that, okay, solids can be categorized based on their arrangement of molecules and also based on the bonding types. So based on the arrangement of molecule, we have just two types, amorphous and crystalline. Well, based on the types of bond, we have ionic, covalent, molecular, and also ionic, covalent, molecular, and metallic solids. So this classification helps to explain the diversity of solids materials and also predicts their physical and chemical behavior in practical applications. So that will be the end of this lesson. Goodbye.